Hi, good afternoon, everybody. I'm Balaji Vembu. I'm an AI systems engineer at Meta. Today, our session is a panel, but what we'll do is in the first 15 minutes or so, we will talk about the contributions of this couple of work streams that we have been working on, and then we'll follow that up with questions. Okay, let me provide some context first. So a couple of years ago, when the whole AI capacity scramble began, it was clear that we needed more than one supplier to fulfill that need. And what we were trying to avoid is bespoke GPU interfaces from each one of these suppliers, which causes the data center tooling to kind of jump through hoops to support it. And then this doesn't really provide any value add. So I just want to make sure, OK. Yeah, OK. So what we needed was we needed to get ahead of this, and we needed to kind of publish a spec at a very short time. So what we did was we formed a very small group composed of 3 suppliers, Google, Microsoft, and Meta. And then, 3 consumers, Google, Meta, and Microsoft, and then 2 suppliers, NVIDIA and AMD. And we started to work on a specification that could hit the road running. So, and these are the panelists. And I will let them introduce themselves when they're talking to the slides. So we'll keep going. So last year, at this time in the OCP, we published our 1.0 specs for these work streams. It was also accompanied by the various collateral, like the Redfish Interoperability Protocol and the Message Registry. And I think Hari from Microsoft covered this on Monday, so you can refer to that. So that's a shout out for some previous presentations which have covered this. And in general, we are seeing success because now we are seeing adoption of some of these, both by the hyperscalers and the suppliers. So in terms of what we are trying to standardize, this picture represents the overall topology. We are focused on the universal baseboard. And to the left, not shown here, is the data center tooling, which communicates with the hyperscaler management controller, which in turn communicates with the accelerator management controller. And that controls and manages the GPUs and the supporting components. So what we are standardizing is the interface between the hyperscaler management controller and the accelerator management controller. To the left, the interface between the DC tooling and the hyperscaler management controller, that is up to the hyperscaler to figure out what to do there. So our focus is that interface that you see right there. OK, now I'll hand it over to Justin.
Thanks, Balaji. Hey, I'm Justin York from Google. So we wanted to start out, just give you kind of a detailed refresh on what we've been doing for the last year, what is the progress that we've made. And so, as we just mentioned, the first thing is the standardization of several new fields in the DMTF Message Registry relating to GPUs. I'm going to go into that a little bit more on the next slide. We've also been finalizing our 1.1 management interfaces spec. And so we're dealing with some errata, making clarifications, corrections. Just to give an example, in the case of long-running MCTP commands, we've added new response codes that let us signal that something's happening rather than forcing longer timeouts. We've been changing some aspects of the header format for MCTP event messages to simplify implementation. We also are working to expand our Redfish Interoperability Profile. So, think of this as our kind of contract between the AMC and the HMC, the Accelerator Management Controller and the Hyperscaler Management Controller, as to what Redfish must be there between our companies. And we want to add some new mandatory properties. And we're also working with the DMTF to modify the SPDM over Redfish to include bitstream support for the component integrity resource. And then lastly, and what we're kind of, plowing forward on towards targeting the end of this year is support for a streaming telemetry definition between the accelerator management controller and the hyperscaler management controller. So diving a little more into the message registry. So this is part of the Redfish feature set. Message registry gives us a way to agree on a dictionary for error and status codes that are important to us and that are common. And what we've done is we've defined a number of response and error codes into that the accelerator management controller can send to the hyperscaler management controller. And this is important because it gives us a way to interoperate to ensure that when we get a certain response code, regardless of the supplier, so from the hyperscaler's perspective, we'd like the suppliers to, where possible, return the same type of error and status codes, and that's what this gives us. It also helps the suppliers because they don't have the hyperscalers coming requesting the same things, in different ways. So that is in part of the DMTF Redfish standard in the platforms resource for the 2025.2 release of Redfish. And I'm going to hand it over to Qian now from NVIDIA.
Thank you, Justin. My name is Wang from NVIDIA. This is a high-level overview of the GPU telemetry effort they're working on. It's been a major focus for us this last year. This is to standardize the GPU streaming telemetry for the GPU UBBs that you see in the diagram there. So far, we have evaluated existing GPU profiles, and we decided to standardize something new, fast, lightweight for streaming telemetry. So our goal is to deliver a model that is transport agnostic and vendor agnostic. So it can be integrated into existing pipelines such as Redfish, gRPC, MQTT, your favorite transport. This model will support both OEM and industry-specific extensions, so vendors could define and expose additional attributes and maintain baseline interoperability while it's integrated by the hyperscalers. So currently, our focus is the out-of-band path. As you see in this picture, is the yellow box, the accelerator management controller connected to the hyperscaler management controller. The standardization occurs where the pink bubble is. What we're standardizing is that the AMC rather, will create a data packet for streaming telemetry, and the hyperscaler management controller will recognize that packet as streaming telemetry and just forwards it on to its final destination and to get decoded and analyzed. And so the detail of that is still work in progress, so we hope to have something ready by end of this year. With that, I'll pass it to Krishna to talk about firmware update.
Thank you, Qian. Hi, everyone. My name is Krishna Sugumaran. I'm going to talk about what we do in the firmware update workstream. Before that, let's do a quick recap. Right? Firmware update is one of the most important critical operations in a data center, AI data center for GPUs, right? To maintain and improve the stability, scalability, security, and performance. Right. In this workstream, we try to provide capabilities that are required to deploy and operate GPUs at scale. And the specification, the GPU firmware update specification, also strives to provide semantics around that, right? So I would like to underscore that in this specification, we are not inventing something new, right? We leverage the PMCI PLDM Type 5 specification and Redfish firmware update, white paper. So we just leverage best of both and to try to fit our use case, right? As you see in the picture on the right, there is this CTAM and hyperscaler software client. Choudary is going to talk about CTAM shortly, right? So I'm not going to talk about that. So hyperscaler clients, CTAM interfaces with the server BMC, hyperscaler BMC through Redfish, And the firmware update is pushed from the server BMC to the AMC. AMC is basically the accelerator management controller, which is the MC for the GPU. So when we say GPU system, it could be a discrete system, or it could be a UBB-based systems, right, where the firmware update is pushed from the server BMC, and the AMC orchestrates the firmware update inside that GPU subsystem. So that's a high-level overview of how a firmware update is done in this specification, right? So let's see what we have done since the last time we met here in the OCP, right? We have released version 1.1 of the specification that includes some enhanced error reporting via Redfish. So we've categorized the error reporting into 3 stages, right? So immediate versus non-immediate versus post-activation. So let me go in a bit detail, right? So when we say immediate, right, so that's nothing but when the BMC pushes the PLDM bundle to the AMC, so the task has not been created yet, right? There are some error scenarios that could happen around that, right? The bundle check might fail, or the size is too large to accept. So any of these could be categorized as immediate failure, and that can be sent to the server BMC by the AMC before a task is created. So that's the immediate. And when we say non-immediate, it could happen, as soon as a task, a firmware update task has been created within the AMC, and during the stages like verify, apply, or copy or apply. In any of these stages, there could be some errors, and that could be sent along with the task, right, in a task. So that's called non-immediate failure. And as the name suggests, the post-activation failure happens after the new firmware, the N+1 firmware, has been activated and up and running. But after that, we also maintain redundancy. So we copy the active firmware, the N+1 firmware, from the active partition to the backup partition to establish redundancy. So things could go wrong there. So any error message could be sent or captured during that stage is post-activation failure. So in addition to these error scenarios, we also worked a little bit on the force update clarification, right? So there were some concerns about how we should, on the scenarios we should handle, right? We spent some time to ratify those. We identified rollback and idempotency as 2 scenarios, and there are several ways to enforce a force upgrade, right? You have the option to do this component-wise in a PLDM bundle, or from the Redfish multi-part updates. So we went with the Redfish way of providing the force update option, right? So that's that, and we also deprecated the use of simple update in favor of push updates. So these are the things that we did in the 1.1, and it will be part of 1.1 specification shortly. So yeah, let's see what's upcoming, right? So last year we talked about min-SVN, right, standardization. We did that standardization as part of MCTP OEM messages. So we went ahead in the last few months, and we are trying to standardize that in the Redfish, so that it's easy and scalable from the Redfish point of view as well, right? And once that is done, we'll work with possibly work with DMTF to ratify that. And in addition to that, we also are adding more clarity around split copy, right, standardization. So this is expected to reduce the overall downtime of the firmware upgrade in the data center, right? When the node is up and running, you would be able to stage the new N+1 firmware and perform the activation at a later time. So that's the split copy standardization, right? And we also are planning to add bundle related, PLDM bundle level signature and security, right? That's coming. And finally, not least, firmware update rate limiting. When we say rate limiting, how many number of times you can perform a firmware upgrade in a given amount of time is called rate limiting, and we'll be adding some rules around that. That's all from my side, and I'll pass it on to Choudary. Thank you.
Thank you, Krishna. Hi, everyone. I'm Choudary Maddukuri. Today I'm going to talk about the CTAM tool. It's a compliance tool for accelerator management. And this is the one which is going to tie everything what we discussed about management extensions, what about the firmware extensions. This is the tool which will make sure the supplier has implemented as per the definitions. And we released the CTAM 1.0 last OCP Global Summit. And we started using internally, and during the last 1 year, we did enhance, we added some features, and later on also we covered some new scenarios, and we are going to release that now. The new features are right now when you generate a full report as opposed to running the full compliance tool across the whole the RIP, we can run in bits and pieces, then the tool will combine all of them as a single report. That is one feature we added. In addition to that, typically when you run this compliance tool initially, you'll find tens, if not hundreds of errors, right? Instead of going through all errors, we summarize at the top of the report so that you know what are the major categories, where it failed and all. That is the second thing. And then we added a feature where when the compliance tool is running and if it fails somewhere, you can there itself pause it and see what is the failure and all, right? That gives more flexibility when you are using the tool. And also we released a executable as opposed to a binary file so that you can immediately download and run it. And in addition to that, while we are using internally, we found new scenarios that we wanted to cover, and we added those extensions also. One of them is earlier, compliance tool was checking against a HTTP push URI-based updates. Now the new one is, it uses multi-part HTTP-based updates. It will do the compliance on that. Then there's a minor enhancement. If you want to do a power cycle, earlier you used to do power off and then do a power on two independent commands. So we added a single command to do both power cycle. And in addition to that, when you are for firmware updates, assume that a package has 10 components, right? PLM components, and not all are compliant, and you know that ahead, so you don't need to run, you can exclude certain components. They only run compliance on these 3 or 4 components. That's what we added. Those are the ones. And last year we did a demo. If you want, you can go and check, it is released. The demo has all the details, and that's all on this one. Okay, call for action. So we did, as earlier our speakers were talking, we published a bunch of spec, 1.0 spec, and last 1 year we started working on the new enhancements we did that we talked, and those are going to, so the spec we published were all 1.0 versions, and after that we did some extensions that also we covered in the new spec. The specs are going through the steering committee, and in next couple of weeks we are going to release the next set of specs. Management spec is 1.1 and firmware update is also 1.1 that you will see, watch for the publications. And also by the end of the year, we are going to add more features. For example, the telemetry. If we can finish sorting out all the details and come to an agreement, we will publish 2.0 versions of both firmware, both firmware update and the management interfaces. So watch for the specs. And as usual, if you have any questions or any suggestions, there's email address. Please reach out at that email address. Thank you.
Okay. If you have questions, please line up. Meanwhile, I'll seed the questions. Of course, these GPUs have existed for a couple of decades now. How do you standardize a part of it now? So I'll ask Justin, how did you go about figuring out what to standardize and what not to standardize?
Yeah, I think we all have kind of the same needs, whether it's suppliers and hyperscalers, which is to not do the same things, especially for basic functionality, you know, over and over again, to have to keep requesting it. And so when we got together, it was pretty easy to converge on things that were painful from both the supplier perspective and the hyperscaler perspective. So we kind of brainstormed a list. Once we had the list, we started scoring them, kind of voting, reached our the top big rocks that we wanted to go attack, and then worked within our individual work stream meetings to flesh those out, come up with something that we were happy with, and then go through the normal DMTF publication.
Great. Looks like there are a couple of people there. You want to go?
Yeah, so I got actually 2 unrelated questions. The first one is kind of on this slide. There used to be a RAS specification that came out of your group. What happened to that since it's not here?
So there is separate OCP presentation that is covering the RAS. We published that also, but in this form, we are covering firmware update and management interfaces.
Okay, but you're still working on that RAS specification as a...
Yes, there is one already published, and we are working on 1.7, I think, that will be published in the next couple of weeks.
Yeah, and there was a session, Anil Agarwal and others who...
There's a session on that one.
And, yeah, and then I have a technical question. So you're calling out a Redfish interface between the hyperscaler BMC and the AMC. What usually Redfish is living on top of Ethernet. What is your envisioning for a physical interface? Because usually don't have Ethernet running inside a system.
I mean, I would say actually Redfish runs on top of IP, and you can run like the TCP IP on top of any physical layer. So, you know, USB is what's present in the implementations, but so it's USB physical transport, but it's, you know, I think standard TCP IP.
Yeah, also we left it open so that each vendor can implement their own. As Justin said, right now it is our USB. We emulated NIC or USB, so that's how it is.
Okay, thank you.
Okay. You had a question there?
Hi, this is Yatish. I'm implementation architect from AMD. I had a question about the force update feature. So force update usually lets you update per component. But the major problem I've seen is if the manifest has a certain feature saying that, hey, you shouldn't be updating below this level, we shouldn't be doing that. But I don't see this being enforced. I would like to see that being enforced so that when you try to update a component and there are dependencies with other components, it needs to just immediately reject that.
Yeah, that's a good question. Thank you for the question, Yatish. So yeah, we discussed about that, and the way we are handling it in this current generation is to apply it on the entire bundle instead of individual component level. If you know for sure, as a supplier, if you know for sure that one of your components is not going to be compliant or not going to be or breaking the compatibility, we are not going to put it in the package. So that's the way we are handling, and instead of there is an option in the PLDM bundle, right? Per component force upgrade, we are skipping over that. Instead, we are favoring the multi-part update, where the force update will be enabled or disabled on the entire bundle, right? And as I mentioned, there are two scenarios, right? Idempotency, so n to n or n to n minus 1. So only in those cases we will enforce the force update. Everything else has been simplified.
Okay,
right? But it's up to the vendor to be to produce a bundle that is fully compliant or fully validated. Right?
Okay. I have another question. This is about rate limiting. So I like when you mentioned the rate limiting is per session. I would like to see this extended for the lifetime of the component, because there are certain components that you can only update certain X number of times. So if you could, I mean, I can work with you, but that is something that I would like to see, because if we can maintain it at the manifest level itself, instead of it going all the way and getting the number of count on how much update has already been done, how many write cycles are available, we can just, at the manifest level itself, we can just say, hey, we don't have cycles for it, so it might error out. Or when you do telemetry, we can know, hey, how many write cycles are left on this particular component.
Right, yeah, again, another good question. So every component has, the destination has different number of write cycles. It could be EEPROM with 100K, it could be VR with
less number
cycles.
of, right?
Yeah. So it is the responsibility of the AMC to keep a track of the firmware update, number of firmware updates that have happened in the past, and whether it is okay to allow future N+1 or not.
I agree, but
yeah.
what I'm saying is if we can do it at the manifest level, instead of letting the AMC do the decision, this could be an immediate response saying that, hey, or a warning saying that this is the number of writes left.
Yeah, we necessarily don't have to deep dive into this, so point taken, and maybe we can work offline.
Yeah, sure.
Yeah.
Thank you.
Thank you.
Thank you.
Thank
Good
you.
suggestion, the telemetry, if it can expose how many rates are left. Yeah, we can come.
Okay. I don't see anybody lined up. I'll ask one more question. So given that the specification popped out about a year ago and all, how easy or how hard was it to comply with this? I'll ask both NVIDIA and AMD. So Krishna, you want to go first?
Yeah, sure. Yeah, again, very good question, Balaji. Yeah, so this specification currently, as it stands today, it's forward-looking, right? But it was not the case when we started. We had to implement all the features, all the features in the product, right? We were not able to meet all the requirements in any, in a single. For example, in AMD case, 300 was the first product, right? We did implement a majority of the features that were needed for a given customer. But I would say there were some areas that were left optional. We did not implement those in the initial product, but as and when it was needed, we would work with the customers and have it implemented. I'd like to add one more, right? The RIP is one of the critical components. We were 100% complete from the get-go itself. And back then we were running, once in a week time frame. But these days we are running it every day. So any given PR that we add in this current generation of products would know whether it is breaking the compliance or not. So that's the commitment we have towards these specifications. Thank you.
And can you say whether it required any hardware changes or mostly firmware or?
In the current generation of products, no hardware changes were needed to meet the compliance, but future products are under NDA.
So we are also committed to the RIP specification, firmware update specification, but I'll touch on the telemetry portion of this specifically. It is, again, also forward-looking. We have proof of concepts in progress, and to answer your second question, it is also firmware implementation, no hardware changes. Again, it's vendor agnostic, so any telemetry methodology that is implemented today, we can apply our new standard model on top of that to create streaming telemetry for whatever data that's being transported today.
Can I just make a comment too? I know we're a hyperscaler, but we also use the RIP, and we have nightly conformance tests that we run against all the products in our kind of portfolio to confirm that as we get drops from our suppliers, that they comply, that we're not going to have any surprises. It's a lot easier to just find the problem at the time of the firmware drop versus after it's already landed on a bunch of developer machines, and now they're scratching their heads wondering, well, like, why is this not working? So it's really valuable for us as consumers.
Yeah, I want to extend on that. We heavily use the compliance tool. We run both on the telemetry and all the properties, but mainly on the firmware update. This has been heavily used in Microsoft. We did some demos also. We showed how to run or how the outputs are there, but it really helps us, right? The supplier has to run this, make sure everything is working fine, no errors. We get it. It's almost like plug and play, but this helps us a lot rather than later on finding the issues and debugging and all. We left shifted the whole effort.
Yeah. So from the stories, you can see that it's been a win-win for both the suppliers and the hyperscalers. The suppliers have had a unified view of what the hyperscalers want, and that way they're not trying to satisfy one hyperscaler versus another. And from the hyperscaler point of view, we're getting a uniform set of features that we can rely on with minimum changes to tooling and all that. Any other questions? If not, we'll give 2 minutes back.
Thank you.
Thank you.
Thank you.